Here's my second example. I have a different curve and a different line, and I will still set them equal to each other and solve using quadratic formula. So first I'll move the 5 to the left side of the equation so that I can set my equation equal to 0 in standard form. And I find that A is 1, B is negative 2, C is positive 2. So my quadratic formula with substitution will be negative 2 plus or minus square root of negative 2 squared minus 4 times 1 times 2, all divided by 2 times 1. To simplify, I need to determine the value of my discriminant. And it's negative 4. Whenever I have a negative discriminant, I'll have imaginary x values. I can't determine what true real y values I have when I have imaginary x values. So if I have a negative discriminant, which means basically I would have 2 plus or minus I square root of 4. You can take the negative out and write it as I, because square root of negative 1 is I. I would get 2 plus or minus 2I over 2. I can divide each of these integers by 2, so I can simplify this to get 1 plus or minus I. However, when I have 1 plus I and 1 minus I for my x values, I won't be able to find real number y values. So as soon as I find that my discriminant is negative, I can stop solving. And I'll just say no solution. And what that means graphically is that my graph of my curve won't cross my graph of my line.